Alright, so this is a continuation of our speed unit. Today we're going to how do we graph motion. Through this we're going to learn three things. One, we'll be able to identify the slope of a distance versus time graph. Two, we'll be able to calculate the slope of a line graph. And three, we'll be able to calculate the different rates using the slopes of a line graph. Before we get through each one of those, we'll start off with the first one, identifying what a slope is and what it looks like on a graph. The steepness of a line on a graph is called the slope. The slope tells you the rate of change. Don't forget, rate is just a fancy word for speed. So how do we calculate speed? We need distance and time. Here's our distance and time graph. Distance is on our y-axis, y to the sky. Our units are meters. Remember, using the metric system, no miles, none of that. Meters, kilometers, centimeters, millimeters, those are good. Our time is in seconds. Scientists use graphs to tell a story. From this graph, we can tell a story from the different runners. The steepness of a slope. Okay, so a slope not only mathematically can be talked about, but it can also just be talked about literally. We can see in runner A that its slope is steep. What does that tell us? Well, if we look at its slope over about 10 seconds, the runner went for 10 seconds. In that 10 seconds went 25 meters. It's pretty fast. How do we calculate it? 25 divided by 10 gives us 2.5 meters per second. If we look at runner C, the slope is shallow. It's lower, like a gradual hill, versus going up Mount Everest to walking up the handicap wheelchair ramp. Runner C, we see starts at time 0, goes to time 25, and only goes a distance of 5 meters. So 5 divided by 25, 1/5 of a meter per second is the speed for runner C. Again, we can tell a story if we're looking at this. Runner A, we can say, is in a sprint. It's going really fast. It's got a really steep slope. Runner B, its slope isn't as steep as runner A, so we can say that maybe runner B is doing a jog. And for runner C, we don't really think he's running at all, and simply can say that runner C is walking. Our distance over time graph are two variables. They have two different units. Since they have two different units, we use this line graph, not a bar graph, to compare two different units. Let's see how this works in calculating it. Our friendly formula is speed. Speed equals distance over time. Calculating slope is rise over run. If you take a look at the colors, they're coordinated with the graph itself. Our rise in red is our y-axis. Our distance in meters. So every vertical bar we see here in red is our rise, and our run, our horizontal, our x-axis, is time in seconds. So each horizontal bar you see in green becomes our run. So to calculate our slope, if we take a look at A down here, our rise for A is only one block up. So if we take a look at that one block up, it's gone a distance from 6 meters to 12 meters. So between that distance, it's only going to be 6 meters. 12 meters minus 6 meters gives us the distance traveled. So our rise is 6 meters. Our run, again, is our horizontal. If you're just, again, think about running, just running horizontal, is between 2 and 4 seconds. If we take 4 seconds minus 2 seconds, we get 2 seconds for that run, that time period between there. So our slope for A, right here, is 6 meters divided by 2 seconds, which equals 3 meters per second. 3 meters, the meters per second is the same unit we use to describe speed. Let's look at slope B. You can see I drew it out a little bit farther. Our rise for this one is now 1, 2, 3, 4 blocks up. It's between 18 and 24 meters. Just take, 18 and 42 meters. Just take 42 meters minus 18, gives us 24 meters of a distance traveled for that rise. And our run is 1, 2, 3, 4 blocks over, which is between times 6 seconds and 14 seconds. Just take 14 minus 6, gives us 8 seconds. So our rise is 24 meters over our run of 8 seconds, gives us 3 meters per second. Same as the slope for A is B. What does that tell us about the runner? It tells us the runner is going at a constant speed of 3 meters per second. So it doesn't matter if I started here, if I counted my run over as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoops, 9. Only went 9.